Hey everyone, we're going to be starting our first lesson today in our new unit on electricity and magnetism. This is a particularly interesting unit, I think, because I think it's very applicable to a lot of everyday things in life, with everything becoming more technologically advanced, everything containing computer parts, or at least to some extent having some type of electronic component on board. Having an understanding of electricity and magnetism and how they interact, I think is really important and very applicable to a lot of everyday items that you will use and come across. So let's get started with our first lesson here on electrostatics. We'll kind of start small, like a pinpoint, and kind of come out from there and take a look at the more macro picture of electricity. But we're going to start with the micro picture. And I say that kind of as a joke, talking about a pinpoint here, because that's kind of what electrostatics will focus on, more having to do with point charges in a way, or charges that are at rest, and how an electric field will look like around different point charges. So to start here, the study of electric charges that are at rest, as well as their electric fields. So electric fields around different electric charges and their potentials, which we'll talk more about later, is what we call electrostatics. So charges that are not moving, this is kind of more of like a ideal scenario versus a non-ideal scenario, kind of thinking with friction. It doesn't mean that electric charges are always in motion, but oftentimes they are in motion, especially when we're talking about electricity. And when we mean at rest, when a charge is said to be at rest, all that means is that there's no net transfer of charge. No net transfer of charge between objects. So we'll kind of do a little bit of a review here about the microstructure of matter. This will be a little bit of a review, things that we would have talked about in chemistry, if you've taken chemistry before, which everyone in this class has. We know that the smallest unit of any element is known as an atom. Not sure what happened there, but this whole thing shifted a little bit. I'll adjust that again later, not now. And we know that atoms are composed of several different subatomic particles, 3 in particular: electrons, which we are particularly interested in this unit, protons, and neutrons. And again, this should be review. Hopefully all remember the charges on these 3 different subatomic particles, and later in the year we'll kind of break some of these down into even smaller fundamental particles. Now the nucleus is always going to contain 2 of these subatomic particles, and it's going to contain the protons and neutrons. And we know the electrons are not in the nucleus, but they are surrounding the nucleus. Now the electron is a fundamental, or the fundamentally negatively charged particle of matter. And the proton is going to be our fundamentally positively charged particle of matter. And again, this is a review from chemistry. And as we move through this first lesson, we'll be pulling up a lot of older information that you would have learned in prior years during chemistry or other classes of matter. Now we're going to talk about a new variable here, which is a lowercase e. And the lowercase e is going to represent an elementary charge. And the important part is that it doesn't have to do with mass, but it has to do with charge. And it's equal in magnitude to the charge on an electron or the charge on a proton, indicated by a positive E or a negative E. And that's really just giving us a shorter notation to refer to positively and negatively charged particles. But we will be referring to them kind of behind the scenes here as protons and electrons, because that's actually what they are. The elementary charge just allows us to use a single variable with positive and negative to refer to protons and electrons. Now the charge on the proton, as I said, is equal in magnitude to the charge on the electron. But the mass of the proton is significantly greater than the mass of the electron. Remember, the electron is extremely small and essentially massless. Neutrons are similar to protons as they're found in the nucleus, but they do not have a charge, and they're about the same mass as a proton, slightly heavier in fact, although we tend to just treat them as equal masses. Now when we refer to an atom, when we hear that word, that's referring to a particle that is electrically neutral. So talking about atoms, we're referring to a neutral particle. Charged particles, remember, we would refer to them as ions. Now in order to be electrically neutral, they have to have the same number of protons and the same number of electrons in order to balance charge. So if you have an element with, let's say, 3 protons, in order to make this neutral, we would have to balance each positive charge with a negative charge. We'd have 3 protons and 3 electrons. Charged objects. Now you've probably experienced this before, and we'll do some examples in class here, but objects can become charged or could cause other objects to become charged. It all depends on how the object likes to hang on to its electrons, and this is going to vary from material to material, and will also change depending on the environment. Now, under ordinary means, you can't just remove protons and neutrons from an atom. Because of this, electrically charged objects are formed by a transfer of electrons, either by gaining or losing electrons. And that's how we get, if you remember back in chemistry, that's how we get an ion or a charged particle, is by the transfer of electrons. Protons and neutrons stay, but electrons will move. They are mobile. Now, electrons can be removed from an atom when the energy is imparted to the atom in a couple of different ways. This can be done either through friction, heat, or light. And if it is exposed to some type of energy like this, it can become a charged particle known as what we call an ion. Now, an object that has an excess of electrons would be considered negatively charged because electrons are negatively charged. And if the object has a deficiency of electrons, it would be considered positively charged. If we had a total of 3 protons and only 2 electrons to match that, we would have an excess of positive charge, so this particular ion would be a +1 charge. If we had an object with 3 protons but had 5 electrons, we have an additional 2 electrons here, so this ion would have a total charge of -2. Now, 2 objects with the same sign of charge, either both positive or both negative, that are located near each other are going to be repelled. So like charges repel. And they'll be repelled by an electrical force. A negatively charged object and a positively charged object that are near each other are going to be attracted. Remember, opposites attract. And they'll be attracted by that same electrical force. So like charges repel, opposite charges attract. Now, as I was saying, objects can transfer electrons back and forth between each other, depending on the types of materials. Less likely to happen if we have the same material, but with different materials and different properties, they're more readily going to gain and lose electrons. Now, if a system consists only of neutral objects, it has a total net charge of 0. Each positive charge is balanced by another negative charge. Each proton is balanced by another electron. Now, if we take two objects that are in a system and rub them together, electrons can be transferred between the objects. This would not change the overall charge on the system, as the system as a whole would remain neutral. We're simply just moving electrons from one spot to another. Consider a sweater here that has elementary particles in and of itself. The sweater is made of matter, atoms, which contain protons and electrons. And at some point here, the sweater might be considered neutral with a balance of protons and electrons. So for each positive charge, we have a negative charge, and we can see that each one is paired up, whether we're referring to the wall, the balloon, or to the sweater. Everything here has a paired up proton and electron and is considered neutral. Now, if we take this balloon and we rub it on the sweater, since these materials are made of, or each of these objects are made of different materials, we can have a movement or transfer of electrons. But would the balloon gain electrons or would the sweater gain electrons? That's going to depend on the object and which one has a greater desire for the electrons. We'll come back to that in a second. Now, if one object in a system loses electrons, it becomes positively charged. Which means the other object that's in contact with the other one acquires the electrons that were lost by the first object and becomes negatively charged. Now keep that in mind. We have a positively charged object and a negatively charged object. So we've gone ahead and rubbed the balloon on the sweater here. We can evaluate the difference in charge. Each of these protons had an electron that has now been lost to the balloon. So the balloon had a greater desire to take the electrons from the sweater, and now we can consider the overall charge on the balloon. Since there is a greater amount of electrons gathered here, this balloon is going to have an overall negative charge. And the sweater looks like it's cut in half here between positive and negative. We have a greater collection of positive charges here, so the sweater is going to have an overall net positive charge. If you think about that, one negative charge, one positive charge, if we bring this balloon close to the sweater, would this attract or repel? So if we bring the balloon close to the sweater, would it attract to the sweater or would it repel to the sweater? I'd like you to think about that for when we talk about this in class. On the other side, if we bring the balloon close to the wall here, will the balloon stick to the wall? I want you to consider the charges in the wall and the charges on the balloon. So if we bring this negatively charged balloon towards the wall, will the balloon stick to the wall? I'd like you to think about this and bring this to class so we can discuss that. Now we're going to end here today, and I'm going to leave you with a short little assignment here with what we have on our notes here. Draw a picture below of a balloon and a hair on someone's head. Be sure to label your diagram and include the correct charges, positive and negative. And I'd like you to draw this with a few elementary charges, showing which one is likely to be positive, which one's likely to be negative if you were to rub the balloon on your hair. You can do a simple diagram, but make sure that you are including correct charges in the right spot. Make sure you bring any questions that you have to class, and we'll talk more about electrostatics next time we see each other. Have a great day, everyone.